Okay, so in this last piece, I want to show you another metric that we can evaluate to understand how the validation set compares to the training set. And we'll look at the standard error. Okay. And the way that we go about doing that, we're going to run a linear regression model and we're going to test using the coefficients from the training model onto the actual values of the validation set, and we're going to extract what's called the deleted residuals. When they'll vary slightly for the validation set, but they'll be identical as to an unstandardized residual for uh, the training set. Okay, what we do with the standardized residuals on the validation set is we square those, and then we get the mean, and we take the square root, and that's our standard error. And we can compare that standard error to the validation set or the training set, excuse me, and we can see if it's increased or if it's about the same. And that's where we're going. And that will conclude just some brief things that we can look at within SPSS, because SPSS doesn't have the capability to do grid evaluation or like hyperparameter tuning or hyperparameter optimization. It doesn't have that capability or much less grid search, right? So that's what we're going to do. Then we'll conclude this session. All right. So here we go. With the data that we have, if you go up to make sure all of our data is selected. Okay, so all the cases are selected. That's what we want. If we go up to analyze and let's go to regression, linear, and we have our variables here. Okay. And then we want to turn on our sample, right? So for our sample, this is how we divided it. 1 meaning the training and 0 meaning validation. Put a rule in here. So we want to run and extract the coefficients for the validation. Excuse me. We want to extract the coefficients for the training. So 1 means we're gonna apply those on the validation. Let's go up here and let's look at our statistics. It looks good. And we want to save deleted residuals. We're going to populate the unstandardized as well, so we can evaluate them. Click continue. Um, we can look at we can evaluate it, right? So predicted and residual, look at our histogram and normality, and then let's click OK. Okay, so what this did is it's going to change from the original model that we did, right? Because the ANOVA here and the coefficient, excuse me, the model summary is changing because it's only on our 80% or the 80% that is the training. Okay. And so this shows the R, right, for the 20%. So it does not equal 80%. Okay. And so we can kind of get a feel of what's going on with our R and the R square, right? This is what changed from the original data. Okay. Our variance inflation factors looks okay. We want remember 1 is great. 1 to 2.5 is fine. We get up to 5, it gives us some kind of like a yellow light. Then we go from 5 to 10, that turns more to like an orange red. So um, and this is all fine. Remember, this is being ran only on the 80% training. So here's where I want to focus your attention though. Okay. Let's look right here. I'm gonna That's the predicted, that's residual, and that's the deleted residuals. So here's what we've got. What you will notice, okay, and we've got the deleted residuals here too. So I've got it here. So we create our predicted residuals, right? And we can extract those from within linear regression. The predicted is obviously, I'm going to clear these first because I already populated them. But what you're looking at with what you're looking at is with our deleted, that has to do with from the training or validation set. Okay. And then if they're going to be slightly different from the actual residual. However, the training set is exactly, but the validation set is slightly different, roughly 3 to 5%. So if you're looking here, that's why there's slight variation. If you look to filter one, which would be our training set, versus a zero, meaning the validation set, there's slight differences off of the predicted Y. Okay. So anyways, I hope you understand. And the reason that happened, it has to do with when we extract out those particular values. All right. One thing that we need to do is to compute a value, and we need to compute it. We're gonna compute the squared deleted residuals. And here a little bit, what we'll do is after we compute it, we'll go through and get the mean of it and take the square root of the mean. And what we're going to evaluate is the standard error. So I already have it populated right here. And so deleted residual underscore one, DRE. And if we do two asterisks, that'll take it to the exponent of 2. Okay. Type that in, click OK. And then we'll see our value populate right there. And then we're going to take the mean of it. And once we take the average and then the square root, that'll tell us our standard error. Okay. And then we see our mean right there. However, I made a little slight mistake, right? Because the values need to be filtered for the validation. Okay. So I'm gonna have to redo this. And you can tell right there it says an N of 208 because our sample should be quite a bit less than that. Should be 80% of, well, it should be 20% of that 208. That's what our mean should be, not the 49,2008. So let's go to data. Let's go select cases. And now let's put this condition on. So sample equals 0. Okay. Click OK. And now let's rerun this. And then we're going to have it a little bit different. There we go. So our mean should be, you can read it there, what, 102? Okay. And then taking us the square root of that will be roughly 10,000-ish. And what that means when we're going to compare here in a little bit, we were roughly 6,000 in accuracy, okay, or standard error whenever we're predicting Y based on these variables with our standard error, and it went up, right? So standard error here, and right here, so 6,082 standard error, the estimate, that's based on our training data. And then whenever, if you take the value that we just computed, that mean based on the validation set, square root of the summation, well, the mean square root of the mean, that's the equivalent of standard error. Okay, and that tells us that we're 10,000, so that's a bit of a problem. So if we go back, thinking the first assessment we did is we looked at a high correlation on the training. Oops, hold on. We looked at a high correlation on uh, the training set, and then when we compared that correlation to the validation, it dropped. And I told you, I said that's predictive of or an indicator of possible overfitting. This is confirmatory whenever we look at the standard error increases. So this says it's a better model when in fact it's actually not. And the way to you remedy to fix that is we go collect more data. So we need a larger sample. So hope you got some good stuff out of this, right? So here's just to kind of show you, there's the 1002 or not 1000, the lots of digits, right? And then when I take the square root, right, so that's our mean and take our square root. Hold on. And here, spell. Because this is a 0, we filtered it, right? Well, I won't hold my comments. Oh, rats. Well, anyways, you see what I did, and now we have another comparison. So again, these are very early preliminary things that we look at to assess model performance, getting into inference and chapter 11. Hope you got some good stuff out of this, and uh, have a good rest of your day. Thank you.